Given in figure 6.1 are the examples of some potential energy functions in one dimension. The total energy of the particle is indicated by a cross on the ordinate axis. In each case, specify the regions, if any, in which the particle cannot be found for the given energy. Also indicate the minimum total energy of the particle must have in each case. Think of simple physical context for which these potential energy shapes are relevant. So this is the first diagram, and as we know that the total energy, that is PE, is sum of kinetic energy and potential energy. Also, we know that kinetic energy, the formula to calculate kinetic energy is half mv square. So mass cannot be negative, this is always positive, and v square, that is this whole quantity, will always be positive. Therefore kinetic energy will always be positive, always. It cannot be negative in any case. Therefore what we can write kinetic energy as total energy minus potential energy. In this case, total energy is E. Therefore, E minus potential energy will be kinetic energy. So, let us see in this situation. For x between 0 to a, we can see that the potential energy, that is P, is 0. Therefore, kinetic energy will be is positive in this region, but when x is greater than a, potential energy is greater than total energy, that is E. This implies that kinetic energy will be negative, and this is, we know that as kinetic energy cannot be negative, and this is not possible. Let us see the second case. This is the second case. As we can see here that for x greater than 0 here, the potential energy is greater than total energy, and total energy here is E, which is for x all greater than 0. Therefore, the kinetic energy, which we know that is E minus PE, will be negative, and this is not possible as we derived in the earlier case. Therefore, the object cannot be present in any place of the graph, in this graph. Let's see the third case. Here for x greater than 0 and x, the region between x greater than 0 and x less than a plus x greater than b. We can see that potential energy is greater than E, which implies that kinetic energy in these regions will be negative, which is not possible. Therefore, the particle cannot exist in these portions. In these portions. For this portion, for x between a A and B, it can exist. Let's see this situation. Here we can see that for the regions between minus b by 2 to minus a by 2 and a by 2 to b by 2, the potential energy is greater than E. Therefore, kinetic energy will be negative in these regions, and for all other regions, the particle can exist. And this is not possible in these regions. Particle cannot exist in these regions.